Okay. Good morning, everyone. So I'm Professor. My name is Phuong-Linh. I'm from Vietnam, but currently studying PhD in National Taiwan University. So I'm the first author of this paper, and with the other master student and under the supervision of Professor Jacob Lin. So we are from National Taiwan University. So the paper is about the worker monitoring using frequency, time-lapse imagery, and 2D drawing. So why we come up with this idea, just because first it's label still the subjects of construction site. So the consultant still rely on the worker, and worker monitoring is the mandatory job for safety monitoring or productivity management. So however, checking workers is like time, effort, burden for site engineer and privacy concern for worker himself. And currently on the construction side, we have a CCTV system already installed for a different purpose, but for example, documentary or security footage every day. And also the time-lapse imagery has provided rich information of the job site activity, but it's still remain like unutilized for further analysis. So we have some challenge for worker monitoring if we are using the CCTV. First is the detection limitation, because worker himself appear in the CCTV part of the field of view is really small, and also the head appear is substantial, so small. So, and also when we do the checking worker with time-lapse camera, if we reduce the frame between different frames, so we will have the challenge here is the worker pose and position have changed after like several times. Like for example, we have in the first frame, the worker is standing, but in 5 seconds after like a several frame, we have the worker already bending, or the position is already moved. So we have revised different tracking methods currently, like dense frame motion using by-check or boss sort, or the appearance-based re-ID checkers. So here, this checking method is like relying on the dense frame and also the very clear appearance of the worker. So in here, we come up with 3 research problems. So first is the worker monitoring still relying on site engineer, and the small object detection in CCTV frames create a challenge for like worker tracking and also object detection. And time-lapse camera has the low frequency. So the current tracking method depends on high frequency frames and generating computational cost and storage for real site adoption. So our research objective is try to propose a worker monitoring framework that integrate low frequency time-lapse imagery with 2D drawings. So basically, the research framework has 3 steps. We have detection with small object detection for CCTV footage, and tracking algorithm for like sparse temporal sampling, and project the trajectory of the worker into 2D drawing. So let's look into the worker detection. So here, because worker appear in the CCTV is smaller than 32 multiple by 32 pixel. So here we adopt 2 different strategies to handle this one. First we apply the slicing aided hyper inference to cut the frame, like the image, into different small parts, and then run the detection model. Here we use Dino and co-Dino is the transformer backbone that outperform for small object detection, and then we ensemble it, the result from Dino and co-Dino using weighted box fusions, like compared to the normal NMS fusions. So here we just combine the result from 2 models rather than just choose which one is better. So then we here is the most hardest part is the worker tracking. So here we treat the difference in frame as 2 different costs. we calculate the appearance cost and motion cost. Appearance cost calculated by the attention reappearance model, and motion cost was calculated by the Kalman filter, and then we calculate the Hungarian algorithm for separately on both cost. So if it consists and match in different frames, so it will be accepted with high confidence. And if it not match, so we forward to the route tool here. So we consider a motion level between between two frames, and a higher motion level indicate that the complex motion and large displacement among the frame. So we will rely on the appearance cost. If it's it is smaller than a threshold, so we will just the motion cost. And then we project the trajectory into 2D drawing. And here the experience, we tested on two sides. The first side is 2K camera, and the second side is 4K camera. So we downgrade the frame rate into 1 second, 3 second, and 5 second intervals to test different scenarios. And we also compare it with the baseline using MOTA, MOTB, and IDF1 for worker tracking, and mean square error, mean absolute error for the whole framework, and calculate the storage and computational time for one-day monitoring videos. So look at the result here. So yellow is our pipeline. So we can see that the MOTA and MOTP and even IDF1 is increased, and but however, here the IDF1 still remain pretty low, so it's still for an open challenge for the future work that the ID still switch if the workers disappear in the field and come back. And so here that you can see the 3 seconds up after the workers already move, so the position is different, and they look exactly the same because they are wearing uniform and also the same hard hat. So this is the most challenge, but we have our model can detect and check the worker like throughout the whole video with 3 seconds per frame. So the MSE here is showing with 1 second per frame as is around 0.3 worker and the whole videos. But come to 5 seconds per frame, it can be 1.4, but this is the MSE. So if we grade on to RMSE is will be around 1.1 workers. So here I think for right now the model still can check the worker in the whole videos with the error is around 1 worker. And but here is the second side is more worker, and with the occlusion is the structural frame itself. So the MS is here as a little bit jump up into 15 and 12 when the frame rate is decreased. So this is still posing the challenge in the crowded scenes for us. We're still working on this. And for worker monitoring in the whole videos for 1 day, so we also compare it with the other tracking model like ByCheck and BotShot. So our error value is just working around 1.4 and 1.13. And storage and inference time that we test for 1 second per frame if we are counting it for 1 working day videos with 2K resolution, it is around 0.3 gigabyte per videos. And if we downgrade it into 2.1 into 3 seconds per frame or 5 seconds per frame, it will reduce around 1/3 the capacity of the storage. And also the inference time here with the videos that 1 second per frame is around 30 hours, and if we downgrade it into 3 seconds, it will be like 1/3 is 45 hours only. So come up with a conclusion here. We have our study demonstrates the feasibility of low frequency time-lapse video for long-term construction worker tracking using CCTV camera. And the comparison between current tracking algorithms so promising for our workflow to further site AI adoption under constrained conditions like CCTV already installed on the site and also reduce the time, computational time and storage. So high frame rate videos is not really strictly necessary for management-oriented applications such as like workforce distributions or productivity-related monitoring, where long-term trends are more critical than frame rate motion accuracy. So the research what extended the current tracking algorithm. The tracking domain is already well developed, but we recognize the resources constraints when adopting the advanced analysis technology on the real science scenario. So this research is forward to like more development from current tracking algorithm. So the limitation we still have like indexed and clouded and occluded since the error still high, and also the experience evaluation is based on a representative videos like just one day. So if we extend this for 1 month analysis, it will be different story. So we're still working on that. Yeah. So thank you for listening. That is current. About my research.
Thank you very much. Any question?